It can be used to replace the original Matlab function, and you can also rename it for poly.m function. And in the top folders in the path of Matlab, then Matlab will search this one first rather than the poly function of the one is provided. And this is one example. The second example. Let's consider how we can find the characteristic polynomial for a symbolic matrix. Suppose we have a vector like this, and A1 through A5 are symbolic variables. Then we can establish a Hankel matrix from it. Let's recall the Hankel matrix. If we assume that the first column of the matrix is A1 through A5, we can construct the Hankel matrix like this. The back diagonal terms are the same, so we can construct a Hankel matrix like this. So what we need to do is to define A1, A2, A3, A4, and A5 as symbolic variables. Then we can construct a Hankel matrix. Like this. We see that the back diagonal terms are the same, so we can construct it easily. And if we have an H matrix, then we can call the poly function to find the characteristic polynomial of the matrix. It could be very long. And normally we can use collect Hx. Oh, sorry, we have to declare x as symbolic variable. And then we can find the characteristic polynomial of it, something like this. The highest term, the x fourth of the term, the third of the term, something like this. And we can find the polynomial of the function like this. And it reminds us that the poly function can be used for numerical matrices and also symbolic matrices. And another topic about matrix is how to evaluate polynomial matrices. Suppose a polynomial matrix is sometimes expressed like this. And A1, A2, and An plus 1 are the coefficients of the matrix. And A is the matrix itself. So if you have a polynomial expressed by A, which is composed by the vector A1, A2, up to An plus 1, then you can find the polynomial of the matrix by coding poly_m function. And if you code this function, you can find the B matrix. So this is another method, another property you have to memorize, the poly_m. And based on this kind of polynomial matrix, there is a very useful theorem in linear algebra. It is called the Cayley-Hamilton theorem. It is stated like this. If the polynomial, the characteristic polynomial of A is given by this polynomial, by this expression, and then if you substitute the operator S by the matrix A into this polynomial, you will have a zero matrix. So this is very important theorem in linear algebra. So how can we verify this? I think you remember this theorem. Do you? Hamilton theorem. This is a polynomial, and if we replace the matrix A back to the variable x, we can have a zero matrix. So let's try to verify it through examples. First, we can generate a one-mode matrix. I'll show you first what is a one-mode matrix. Well, for a one-mode matrix, the last column is 1, and this column is the number I used, 1 to 7. And this column is the square of this column, of this column, the C column. And this column is the cube of this column. And this is the fourth order power of this column. So a one-mode matrix can be entered in this way. So for this matrix, to verify the Hamilton theorem, what we need to do is to the name is A. So what we need to do first is to find the characteristic polynomial of the matrix. It is something like this. We can find the characteristic polynomial of it. And then we can call the polyval M function C A. And here we may expect a zero matrix. However, it seems that the result is not zero. And in fact, if we find the norm of the matrix, we find the error could be very large. 10 to the 6th power could be a very large error. So why we get this kind of erroneous result? The reason is the poly function provided by Matlab is not accurate. There are something wrong. There are some errors in the result because it uses iterative eigenvalue-based algorithm. So there might be errors in it. Now let's replace the poly function by poly1 function. And then if we call this function again, we can get a zero matrix, which means that we should not rely on too much on the poly function of that. If we really need it, we better use the poly1 function. And the poly function may lead erroneous results. So you must be very